We're here with world-renowned artists from all over showcasing how they use Cinema 4D in their workflow. One of them is a longtime artist. I've had him out to many shows, but first time to the main stage. Welcome the creative director and founder of Fiveten Giant, Purdy.
So welcome to NAB in Vegas. Welcome, Internet. Super excited that you guys had literally nothing else to do other than watch my presentation. So that's fantastic. As Matthias said, a little hot. Not hot enough? Are you telling me I'm not hot enough? Okay. So as Matthias said, I'm Purdy. I co-founded a small outfit out of Southern Indiana called Fiveten Giant, and today I'm here to show you how we rigged up an autonomous, fully autonomous, no keyframe vehicle for a project we were approached by Revell and Seam Studio in conjunction with Microsoft. So have you guys ever heard of Halo? Show of hands, yeah. All right, Rick, I need you to show me a tally on how many hands were raised on the web, please. And, oops, wrong one. All right, so first I'm going to show you a little bit of what we do over at Fiveten Giant. I think I have sound. Yeah. Thank you. So I'm super excited to be here at NAB, and I'm also very excited that they organized it in such a date to where we can all be home ready for the premiere of Game of Thrones and Avengers Endgame. So first, I'm going to talk a little bit about the animation before we dive in. So I'm just going to kind of play the full animation for you. All right, so I'm going to put this on repeat. I'm going to talk a little bit about how we work this out. So when they approached us with this project, it was kind of a budgetary and time thing that we weren't super happy with, which I'm sure you're all familiar with dealing with that. That's par for the course. So what we wanted to achieve is we wanted to get this Halo Warthog moving across terrain in a very natural, fluid way. And I didn't feel like we had the time or the money in order to keyframe this all up. So we looked at the dynamic system, which was a lot of learning for me, especially, in order to kind of try to do this with no keyframes. So you can see that we use X particles, we use substance to bit out the environment, Cinema 4D for everything else, and then it was rendered with Octane. So this was actually a 3D scan model that Revell sent us, and they sent me like the entire model of this thing. So I've got this thing spread out on my desk like a small child trying to figure out like how to put this together, looking through the instructions, and so yeah, I have one at home. So let's go ahead and dive in and do what you guys are here for and show you how we set this up. So I'm going to load the first scene. And I'm going to talk a little bit about kind of dealing with CAD models somewhat. And this project was about 2 years ago. Since then, R20's implemented a Cad Loader, which is absolutely... I didn't start the timer. Wow, shame on me. I guess I get an extra 10 minutes, Matthias. The Cad Loader is amazing. I've used it. 90% of what we work with is CAD models. So just really heavy data, really messy geometry. and we needed to shove that into dynamics. Now, if we go ahead and go to the options menu and turn off the textures and turn on our garage shading wood lines, look at this mess. It's an absolute travesty. So now the dynamic system can handle this, okay, depending on your computer. But you're not going to get smooth playback. You're not going to be able to see your animation playback in real time and get the full look of how it's supposed to look without rendering it out. You don't want to have to render it out every time you want to see your weight, your inertia, your sliding, your suspension. If you try to shove this into the wrong computer with dynamics, you're likely to open a space-time portal in your office, which is actually a feature of R21. Why do you think we have the big Stargate here? So I'm going to show you a little bit how basically what we want to do is we want to organize this thing into the parts that are going to be independently dynamic. So you have all four wheels and you have the body. So we need to organize this Halo Warthog in such a way that we can get it rigged up for dynamics. So if I go into polygon mode, actually I'm going to select one of these wheels. And you see here I have front tires. I need these to be independent. So if I go to polygon mode, you can see that I have 2 tires under one mesh, which isn't going to work for me. So I'm going to use a function or a selection tool called the fill tool, UF on the keyboard, or you can find it under the select fill selection tool. And we're going to select all the adjacent polygons and selecting none of the unconnected polygons. And then we're going to right click and use the split command or UP on your keyboard. And you can see now I have a tire based on my selection that is fully separate. Problem is, I also still have that tire under the front tire. So I'm going to hit delete on my keyboard. Now, if you're using R19 or lower, go to maxon.com. Shame on you, buy R20. But you will be left over with a bunch of points. And if you're trying to follow along or do this with a car yourself, CAD model, all you need to do is select all of the points or none of the points, go to your optimize command, and just use a super low value like 0.0001, and then all the points that were left over here in R19 or lower will be gone. All right, so let's go. We got a couple more things that we need to separate out on our wheel. Right, we got our hub here, polygon mode, UF on our keyboard for the fill tool, split that, hit delete, and then we need to do the same thing for our center cap. Polygon mode, UF, select, split, delete. Whenever you're doing this, you want to make positively sure that if there's combined meshes, that you don't have extras that you're not seeing. For instance, the tires were combined into one mesh. The front 2 tires, the front 2 hubs were combined in one mesh. However, the center caps were combined in 4 meshes. So pay special attention to what you're grabbing. All right, so we know that we want these organized into their dynamic counterparts. So we're going to take our wheel center here, put it under our front tire dot 1. We're going to take our front hub, make that a child of the front tire. Now, you're going to notice one more thing that you need to do. If I go into model mode and I select my front tire, watch this. Now, I'm not a mechanic, but I'm fairly confident that that's not how a car works. So what we need to do is we need to center the axis to the average of all the polygons. So neat little trick here. If you middle click anything, it will select everything below it. And there is, under the mesh menu, an axis center tool. There is this center axis to function, which will take the average of the polygons and points and put the axis dead in the center. So let's go ahead and click that. And even though I have all these selected, it's not just centering the axis to the top parent. It's actually doing it for all of them. And you can see that if I individually click each one of these, they all have their own center axis, but everything is controlled through parenting. Now, I'm not going to go through doing all the 4 wheels because we want to get to the fun stuff, you know, making this thing slide around and flip and do cool cool stuff. Man, I keep wanting to use profanity because whenever I worked on this project, it was a lot of profanity flying out of my mouth when I was dealing with this. But I've heard that's not good form for a presentation. So I'm going to go ahead and load up the scene where I actually have this done already, where the meshes are already organized. And I'm going to give you an idea of what happened here. So you can see that I've organized everything having to do with the body in its own null. And I've organized everything with each wheel in their own nulls as well. You can see that the same parenting structures there, it's just under a null now. Now, one thing that I did do that I didn't in the last scene is I used some sort of relative naming conventions that make sense to me. Otherwise, you can get really confused when you start tying rear suspension 1 to back wheel 2 and things like that. So you want to try to stay organized as best as possible. I'm not a very organized person. I'm trying to be better. So now what we want to do is we want to build proxy meshes. You remember me telling you that you really don't want to feed this kind of topology into the dynamic system. You're talking about the dynamic system trying to calculate each individual polygon where it hits the floor, and that becomes cumbersome. You could do it depending on your computer, but you don't want to. So basically what we're going to do here is we're going to build out simplified meshes, proxy meshes that are low level, very simplified for the dynamic system to push out quickly. So what we want to do is we want to encompass each of these things in one of those proxy meshes. So I'm going to create a cylinder here. And I'm going to size that down just a little bit. And I'm going to use a tool that people sincerely do not use enough. So I'm going to hit Shift-C on the keyboard, and this is where you can have access to anything in Cinema. I don't know how many times I've looked through the menus trying to find something, and I'm like, where the hell did that go? So just use Shift-C on your keyboard, and we're going to use something called the transfer tool. And I'm actually going to drag this up to my interface because I know I'm going to be using that multiple times, which makes it easy because then I don't have to hit Shift-C, type transfer, everything else. So what I want to do is I want to transfer this cylinder's axis, center point, to the driver front wheel so that they're in perfect alignment. So let's go ahead and hit the transfer tool. And this allows me to, you can't see it if I get under here, click on objects that I want to center this to. But I'm going to be a little safe about this because sometimes if you click the hub, the axis is just a little bit different than the tire. I am going to drag the whole front wheel into here. And I don't want it to take on the wheel's scale, and I don't want it to use this rotation. I want to do that myself. Click Apply. So now those two things are synonymously aligned. So let's rotate this guy around. And I'm holding Shift to quantize. Fun tip. If you ever need to quantize something at 45 degrees and not 40 or 50, go into mode right here in your attributes and go to the modeling and the quantize tab and change your rotation to 5 degrees. So now anytime you rotate something and hold Shift, you can get that magic 45 degree number. So let's go ahead and encompass our tire and our wheel with this simplified proxy mesh. And we want this just to be a little bit outside or a little bit inside the tire because we know that tread compacts, when it hits. So the little bit of the tread is going to go into the floor. All right, so we have our first wheel. Now we need 3 more, right? So Control-C, Control-V, V, V. All right, and we need to transfer these cylinders as well. So I'm going to hit the transfer tool, and I know I'm about to use this 4 times, so I'm going to lock this interface so that this doesn't disappear. And I'm going to transfer this to the passenger front wheel. Hit Apply. Transfer the cylinder to the driver back wheel. Transfer the cylinder dot 3 to our passenger back wheel. So the other thing that we need to do is we need these to be the parents of our wheels. So we're just going to drag these down here, drag them under their respective proxy mesh. All right, now watch this. I click the cylinder, and I have complete control over everything underneath of it. Now, you don't want to see these proxy meshes in your final render, obviously. So you can simply just red light your proxy meshes, which is going to say everything underneath of this stoplight needs to not show in the render or the viewport. And then you hit the contradictory green light where it turns everything else and ignores the red light. So now we have control over that. Now the other thing that we need to do is we need a body. That body is going to be tied to the wheels for suspension, for weight, for inertia. It's going to drive the whole thing. So I'm not going to go deeply into box modeling this out because, again, I want to stay on time. But I'm going to go ahead and create a cube. I'm going to unlock this, go into my basic tab, flip on X-ray mode so I can see what's going on. And then I'm going to go into my other viewport and get this kind of to encompass the body as a whole. So let's go back out into this view. So now we have kind of the shape, the basic shape of this object. I'll pull that in a little bit. So what I did after that was I hit C on my keyboard in order to convert it to an editable mesh. And I used various modeling tools like the ring selection, UB on the keyboard, which allows me to select rings of loops. And say we're going to use the edge cut and turn off create ingons. And this is going to give us an interactive cutting tool to kind of divide this up a little bit. Now, the most important thing about what shaping this out is you need room for the wheels. You need wheel wells. You need those wheels to be able to turn and bounce and not hit this mesh. Otherwise, it'll cause craziness, time portal, you know, Stargate, all that stuff. Or just, you know, wheels flying all over your screen, which is kind of fun. And we can use the handy-dandy new knife tool, which is K on our keyboard, and you see that it pops up the available options. We can do a plane cut through, or we can do a line cut, or we can do a loop path cut. So we're going to do a loop path cut, and we're going to cut this just above the wheels, and we're going to cut this here, and then we're going to start shaping these out in order to get kind of just encompass the body. This is especially important if you're going to do any sort of collision. If this thing's going to hit another vehicle, you need to have it pretty spot on with the proxy mesh. All right, so I'm going to go ahead and load up the one where that is finished. All right, so you can see my proxy body here. Hotkeys are not the same. It's pretty simple. You know, I just box modeled this to make room for the wheels so they have room to bounce and turn without touching the body, which in real life, ideally, again, I'm not a mechanic, but I'm pretty sure you don't want your wheels to touch the body. So this is kind of where we leave off with the proxy mesh. The only other thing that I did was I applied a checkerboard texture to our wheels, which I have an octane material here, but it's really simple. In the texture, under surfaces, you just pick checkerboard. And then you have a checkerboard texture for your wheels. This helps you see if it's rotating in the right direction, everything's working okay. So we're going to leave this looking just like this for now. So now we're actually going to do the fun part, and we're going to start getting the suspension and motors in order and get this thing working. So the first thing we know we're going to need is a floor. So let's put a floor in here. And I'm going to rotate under here. We do not want the wheels penetrating the floor right now. All right, so the suspension system is actually not its own suspension system. It is built into another tool under the Simulate tab, Dynamics, a connector. And the connector has a plethora of options that you can use, anything from a hinge to a ragdoll, anything like that. But we are going to choose wheel suspension. I'm going to hide the floor from the view. So now we have our first connector, which is our wheel suspension. And what we want to do is we don't need to change a whole lot in here, but we do need to tie the body to the wheels. So this first connector, and we know we're going to need 4 of them, right? So copy, paste, paste, paste. So let me go ahead and group these, actually. And we'll call that susp. There's also a spell checker in R21. I don't know if you guys knew that. Just kidding. So the first connector, we're going to drag our proxy body down into our object A, and we want to connect it to our lower wheel. And I'm just kind of going in order from bottom to top. Eventually, you're going to name these things to correspond with their respective connected objects so you don't get lost in the future or accidentally move this up here and you don't know what you did, which happens. It's never happened to me because I usually do everything great, but which is a lie. So we want to connect our other wheel, and then we want to connect it to, and we can actually just select all these. We know the proxy body goes into the object A for efficiency's sake, and then each connector drag the wheel in here. Now there is one important thing to note that I did do that it did not show you. I think I did it. I hope I did it. I didn't do it. Wow. All right, so for some reason when you're dealing with suspension dynamics and motors, you want these things to be in their own 0, 0, 0 axis. So you look at this passenger back wheel. This coordinate system and this rotation is in relation to the middle of the world. So it's saying from the middle of the world, we are negative 38 in the X, negative 24 in the Y. We want to freeze that transformation so that it is actually in its own already 0, 0, 0 state. It's in its own local axis. So we're going to do that for everything and freeze that. You don't always have to do this, but it's just a good practice. If you start to run into issues with things not working right, that could very well be what it is. And we want to 0 freeze. Right. All right. So our connectors, they are not on the wheels. They need to be on the wheels. So I'm going to use the transfer tool once again, and I am going to set this connector to the same position. I do not want to enable the rotation and scale. This connector, transfer, lock this to this wheel. This connector to this wheel, and this connector to this wheel. Again, we just use the transfer tool to move them into the exact midpoint of or axis of the objects we're tying them to. Now there's one other thing in here. We need our connectors to face outwards. Right now they're facing the wrong direction. So for efficiency's sake, we're going to use the rotate tool. Now look what happens when I try to rotate all of these. It rotates them as a group. One not commonly known feature to some, let me unlock this, is when you use the rotate tool or certain other tools like scale and things like that, you can go into the object axis and turn on per object manipulation. So now when I rotate these around, they're rotating on their own axis, which allows me to rotate many things where they're supposed to be. All right, so we have our connectors, we have our suspension connected, that's all good. Now we need some motors. So under the same simulate menu, dynamics, we have a motor. So we're going to do the same thing. We're going to create 4 of them. Copy, paste, paste, paste. Group. I'm just going to group these up. I'm going to hit Alt-G on my keyboard. And I'm going to name this motor. Yeah, that's fine. Again, that spell check, Maxon, we need it. So the motors, we're going to connect the same way we did the suspension. So our first motor here, we want to say we want the wheel to drive the proxy body. Same thing here. We want the wheel drive the body. I'm going to select these 2, throw the proxy body, and then drag this wheel in here, and our last wheel there. Now, there's a problem. the motors are not oriented in the correct direction. The motors are not as temperamental, or they're not as needy, say, as the wheel suspension. The wheel suspension needs to be on the wheels, you know, like real life. The motors, unlike real life, do not need to be, or they need to be oriented correctly, but they don't need to be transferred to the axes. So we're going to do the same thing. We're going to hit the rotate tool. And do I have that locked? There we go. We have per object manipulation still on already. So we're going to rotate these guys around so that they're going the right direction. All right. So now that we have our motors, now that we have our suspension, if I hit play, nothing's going to happen because these things are dynamic. They react to dynamics. You need dynamics in the system. So the first thing we're going to do is on our floor, we're going to put under simulation tags a collider body tag. This collider body is saying, okay, anything is dynamic, I'll interact with, but I myself will not move. So let's go ahead, and that's all we need to do for the floor. Now, all of our wheels need dynamics tags. So we're going to go to simulation, rigid body tags. Now, we don't really need to change anything on here right now. Eventually, we're going to work with the collision, or I'm sorry, the friction a little bit, so that the tires grab depending on the torque of the motor. And we need one more dynamics tag on the proxy body. So let's simulation rigid body tag. Now we do need to change something on this. Reason being is because by default, to simplify the dynamics, the shape is set to automatic. Now, as you can see, the automatic is going to say, all right, what's the widest point this way and the widest point this way? Okay, we're going to make a box this way. What's the longest point this way and the longest point this way? And it's going to just create a simple six-sided collision shape, which is going to intersect it with the wheels, time portal, all that. So let's change this shape to moving mesh, which is saying I want you to treat this like a collapsed mesh. I want you to look at the angles of the polygons, where they are. I want you to look at the whole thing. If you were to do this to the body of that CAD model, it just wouldn't be good. Don't do it. All right. So moment of truth. We're going to hit play. I can't promise anything, but yeah, let's see what happens. Perfect. That's my presentation. Tip your bartenders, tip your waitresses. Have a good night. Drive safe. All right, so right off the bat, this object, this proxy body, is given a weight based on its size in world space. So what we need to do is tighten up the suspension. So we're going to go to our dynamics tags here, hold shift so we can select them all and manipulate them all at the same time. Oh, nope, we're going to go to the suspension, actually. So we need to raise the suspension stiffness to something that is going to support all of this weight. Completely arbitrary number, 45. I didn't plan that at all. And let's see what we get. Okay, now the reason the car is moving forward is because the motors have an default angular target speed, which is basically the speed. So we're going to set that to 0. And we're just going to make sure this thing is sitting how we want it to. So let's drop that to maybe 30 and see what we get. That's not bad. Now, your suspension dampening is basically your shock absorbers. Now, you can see I'm going to turn down, and if you need, if these things are getting just obnoxiously obtrusive, you can go to the display tab of these and set their display size down to something like 25. And you can see closely that they actually react. Now, what we can do here is we can up the suspension dampening, and what that's going to mean, it's going to go back to rest quicker. So just to illustrate that, let's set the suspension stiffness to something lower, say 20, and let's turn our suspension dampening, I think it was 10%. All right, you see how much rocking and stuff we have? All that body roll and chassis shift. So we turn our suspension dampening up. You see you get a more realistic feel out of it. And this is all just kind of playing with values. It depends how big your object is, what your proxy meshes look like. Obviously, if you make a big semi that has a proxy mesh that goes 10 feet in the air, you're going to get a different result because you're going to have more weight. So we're going to turn our suspension stiffness back up, 35. All right, that looks good. Now let's make sure our motors are working. So let's turn our angular target speed up to, say, 1,000. All right, we're getting a pretty slow start. So what we need to do is we need to up our torque. We need to up how hard those wheels are spinning. So let's up that to something ridiculous. And now we're spinning. So what we need to do now is, you can do this two ways. You can up the friction on the floor, you can up the friction on the wheels. It really just kind of depends on what you're going for. You might want more wheel control because you might want the back end to slide around a corner or something. So you might want to just control that with the dynamics tags on the wheels instead of on the floor. But for now, we're going to up the friction on the floor. Whoa, no, we don't want to do that. It's going to be like driving across a giant piece of tape. All right. All right. Now our Warthog is driving. Now, just for the sake of fun, let's toss in a little cylinder here. Bring this guy over. Let's add a speed bump. Now, there is actually a practical application of this. I want to test the suspension and see how it's going to react to the terrain, because you don't want the wheels pushing through the body. So we're going to drop that down a little bit because we don't want it to wreck. We want it to actually go over the bump. All right, so let's get kind of tight in here and watch this thing go across this and see if the suspension is reacting how we want. Oh, yeah, I might need a dynamics tag on that. That doesn't happen in real life. You don't go through stuff like that. Collider body. There we go. That's all we need to do to it. All right, the suspension seems a little tight. So you might want to play with that a little bit. Actually, I will just because I'm picky. It's a little better, maybe like 15. There we go. Now we're getting some, let me deselect these. Now we're getting some bounce and some more shock absorption or less shock absorption. All right. So now we're going to move on because we want to tie all this together and control it, right? So I'm going to show you how to set up steering and control speed through user data. And then after that, we're going to go full autonomous, full Tesla. This thing's going to drive itself. You guys are going to be amazed. Give me a standing ovation, and it's going to be, or I'm just going to say, you know, Game of Thrones or something to get you cheering, and have Rick like edit that out. All right, so let's load up our dynamics. So this is where I've already done this. All right, so we're going to delete this guy out. Okay, so user data. Basically, we are going to create. I'm going to hold Shift on my keyboard and then click null. What that's going to do is that's going to make anything that I have selected, anything that I click is going to become a child. If you hold Alt, anything you create becomes a parent of your selection. If you hold Shift, it becomes a child. And we're going to name this controls. All right. So how many of you are actually familiar with user data, using the user data? Okay. So let me blow your mind. User data is a way to create, over in this area, a new interface of your choosing. You can create these drop-down menus, sliders, checkboxes, have separators, name them. I mean, it's pretty sweet. So I'm going to show you how to do this. I'm going to add user data. And don't get too bogged down by the interface or what I'm about to do. I'm going to add a group, and the reason being is because it's going to create a new tab over here, and it's going to be called user data. And I can't change that name. I don't want to see user data. I want to see Warthog controls or like something that doesn't say user data. So I'm going to add a group down here. I'm going to pull it out. I'm going to pull my first data group down here. Now my group I am going to name controls. Let me give you a quick tip on using this user data. Do not hit enter. You're going to do it. It's going to happen. I'm going to do it in this presentation. I'm telling you not to do it, and I'm going to do it. I know it. But it will just hit the OK button, and you'll be done. So when you go to name your data tab, say something like speed, and you hit enter, you got to go back into the user data and load up the manager. So our data type, we'll just leave it as float, and our interface is going to be a float slider. If you want to see what it's going to look like, there's a little example tab over here, and this is what you're going to see down here. So we have our float slider, and a percentage is fine. We want to go from 0% speed to 100% speed, and with Espresso, we're going to convert the percentage into actual angular target speed. We're just trying to set up the skeleton of our controls right now. So I'm going to copy this up, and we're going to call this steering, stirring. Same float slider. Steering, we want left, right, right? Say we want to limit that to 45-degree turn left, 45-degree turn right. So we're going to say our minimum needs to be negative 45%. Oops. And our maximum needs to be 45%. And we want our default value to be 0 because that is straight. All right. I think I got everything here. Now we're going to hit enter. Now we have this controls tab here. Look at this. We have our handy dandy little sliders. Our steering left, steering right, speed. Now we just need to tie those things together, and we're going to do that with Espresso. How many of you use Xpresso? All right. Bloody hell. We are going to go to Cinema 4D tags, and we're going to put an Espresso tag on our controls. What Espresso is a node-based kind of visual way to manipulate objects in your scene and throw data at it and have it do it. You can basically make games in your viewport with this. Actually, Chris Schmidt has done it. So what we want to do is we know that we want to control our speed. So you can just drag things into Espresso. Now, I can't go through the full breadth of Espresso. I'm sorry about that. So I'll try to explain as much as I can about what I'm doing. We're going to drag our motors in here, and then we're just going to organize those. And it works similar to the viewport in Cinema. You know, your alt-right click zooms in, your alt-middle click pans. You can't do any rotation. And these blue blocks, I'm going to optimize these. These blue blocks on the left are input. This is where you can input values. And we know from our motor that we need to input angular target speed. We need our user data to send information to our angular target speed. So we're going to select our input, go to Object Properties, Angular Target Speed. Same for all of these. All right. So now we need our controls null in here because our controls null has our controls. Drag that. And now we need to output these values into the inputs of our steering and our speed. So we're going to go to controls, and we're going to say we want to control the speed. Now, I could plug this in. If I plug this in right now, it's going to say, oh, yeah, 1% converted to angular target speed. So it's trying to convert a percent to a degree, and you can't do that. So we need a middleman. And that, my friends, is a range mapper. So we're going to go to New Node. Where is calculate? Oh, there we go. This is a range mapper. This converts one value to another. So we're going to plug our speed into this range mapper. Now our range mapper input is what? percent, right? Because our control slider is percent. So we're going to say the input that we're sending in here is going to be in a percent value, but we want our output to be in degrees. And now this is really simple here. Our input lower is the lowest point of our slider, which is 0%. Our input upper is the highest point of our slider, which is 100%. So now we tell it how many degrees we want 0 to be and how many degrees we want 100 to be. And I just happen to know from trial and error that 2,000 degrees angular target speed is about as fast as I want this thing to go. So now, if I plug this in to the angular target speed, I should have control of the speed. So let's just test it. We're going to set our speed set to 0. And we can see we have this little new icon that's not a dot, and that means it's Xpresso controlled. It's linked in some way to another object through Espresso. So we hit play, nothing happens. Turn our speed up. Stops, full speed. And I'm not a mechanic, I'm not a doctor, but I'm pretty sure that you shouldn't do that either. Apparently I used a cube instead of a floor in the scene. My sincerest apologies. So now we have our driving, right? So we want to go back into our Espresso. Now we need to control the steering. We know that the front wheels are the only ones that need to steer. So we're going to drag those over into here. And the steering is controlled right here in the steering angle. So I'm going to optimize these because it looks prettier. And we want to input our steering angle. So we want to feed a value into this steering angle. And this is going to be a little bit simpler of a setup than this. So all we need to do, since our control slider is... okay, I need to manage user data and change that to degrees. I think... negative 45. 45. Oh, hit enter. Oh, my God. See, I told you I was going to do it. And we want this to change by 1 degree and default value 0. Yeah. All right. So we're fine here. We can just actually use this same node here. And we want to output steering. But we don't need a middleman because the steering slider is already in degrees, and we're outputting in degrees. So let's go ahead and drag this over to here. And let's see if it works. Fingers crossed. Let me make a floor because I'm kind of running out of road. All right. So we're going to select our controls. We're going to set our speed something low so that we can see our steering. Now these dynamics, these controls aren't going to work unless you hit play. So you got to hit play. You're not going to see steering happen if you're on frame 0 and you're moving the steering. So we're going to give ourselves more time. I'm going to double click on drag. All right. Okay, our Warthog is moving. Let's see if our steering works. All right. Is it backwards? I think it's backwards. So that's just something simple in the user data that I need to reverse and fix. No, that's not going to fix it, actually. Steering. I blame Sabor for this. He's my scapegoat. Anything that goes wrong in this presentation, he takes the blame for it. It's actually fine. I'm not sure why that's doing that, but we can deal with it. All right. So this is how we did the power slide. And if I load the power slide here, actually, you know what? Let's do something fun. Let's turn the speed all the way up. Cut the wheel. And do some donuts. Now, probably need a little more torque and a little more friction on the front wheels, and maybe take some of the friction down on the back wheels, because it's kind of bogging down from the weight and the friction. You just need more torque. But I can show you the power slide that we did, which was really simple. And this is the simple setup that I did for this slide that you saw at the end of the Halo Warthog. I have a camera connected to this so that we can see it run in real time. Spinning up, cuts the wheel, slides. And then if we cut back to our ground cam here, you'll get kind of a little bit of what I'm talking about. And you see the chassis shift and everything. That is a result of using the dynamics and playing with the suspension and everything like that. And it works so good. I was so impressed with the dynamic system in cinema. And this project came together so well because of it. You know when you get too drunk and you go to Taco Bell and you order 75 tacos and they only give you 2 packets of sauce? Yeah. It was the opposite of that. It was like watching a prescription commercial that doesn't have 75 life-ending, side effects from it. It was just something that doesn't happen. And it was so perfect. It's the only time it's ever going to happen in my life, so I'm going to relish it. All right, so what we want to do now, and all I did here in the controls is just turn the speed up. So our speed goes up, takes off, turn my body cam back on. Our speed picks up, cut the wheel, cut the motors, and then turn the wheels back a little bit so we get a prettier angle. Yeah, one thing with dynamics is unless you cache them, you can't just scrub the timeline. So, yeah, you get the point. All right, so we need to move forward, and we need to go to building this out autonomously. So I'm going to go ahead and load up my next file. Auto follow. All right. So what I've set up here is a simple spline that I've drawn, and I took a sphere and I used an align to spline, which is Cinema 4D, align to spline, and I have just keyframed the position of that across the spline. We want our object to follow this. If it gets too close to this object, we want it to slow down. If it gets too far, we want it to speed up. We want it to just stay in a target range and control its own steering, control its own speed. So, excuse me. All right. So we're going to set up something similar to what we already did. We're going to go into the controls, and what I've done is I've taken the sliders out. We don't need controls for this. So we're going to build this in Espresso. So just like before, we need to feed something in to control our steering and our angular target speed. All right. So in order to do that, we first need to set up something to control the steering, right? We want something to control the wheels and point them at the sphere. Now, I'm going to make a cube. And I am going to size this cube down. I'm going to bring it up to the center of the Warthog, and I'm going to rotate it. Now this cube is pointing in front of the vehicle. We're going to use this cube to point at the sphere, and that cube's heading rotation is going to control the wheels. We're also going to use that cube to decide what the distance is between the sphere and the vehicle so that it can speed up or slow down. All right. So we're just going to call this pointer. And we're going to put it as a child of our proxy body because we want that thing to move with the body. Next thing we're going to do is we're going to put a target tag on our pointer, and we're going to have it point first thing I want to do actually, which I always forget, turn off the pitch. I don't need to control the pitch. I just need to control the left-right. All right, we're going to drop our follow target into our target object. And now let's hit play and let's make sure that our cube is reacting. And we can see that it's slowly turning. So now we're going to use that cube to feed back this heading angle here that's changing back to the wheels. There's one thing that we actually need to do, though. We need to clear this back out, because one thing I forgot to do was zero out the position, scale, and rotation. So I'm going to freeze this so that it's now 0 degrees pointing this way. It's no longer negative 180 because it's going to mess up if you do that. All right, now we're going to drag our follow target back in. Right. We'll go into our Espresso. We're going to drag our pointer in here. And this thing, this globe, or I'm sorry, not the global, the rotation H heading is going to control our steering angle. So let's just find out if that works. Our wheels are turning with the cube. So we're getting exactly what we were looking for. All right. So now we want to get our speed controlled. So we're going to use what's called a distance node. And I believe that is in calculate. And the distance node is going to calculate the distance. Calculate the distance between their pointer or cube and our follow target. So we need our global position of our follow target and our global position of our pointer. We're just going to rearrange that back up here. We're going to feed that into input 1, feed that into input 2, and then there's this handy little result node in Espresso, general result, and we're going to feed that over into the result, see what our base distance is at the start. So right now it's 460 units, so let's just say we want to stick somewhere in that range. That's a comfortable range. Right. Let's angle this up. All right, so we need to add in a range mapper real quick. And say, basically, if, you know what? I need to look at something real quick, because I think I just forgot something. No, I didn't. How embarrassing. So we need to just throw in a range mapper, and we need to convert this value over to an angled speed. Right. And our input value is just a number, so it's user defined, and our output value needs to be in degrees. So we're going to say if our input lower, say 100, if we get within 100 units of this sphere that we're trying to follow, we want our motors to stop, so 0 degrees. If we get 500 or more, we want those motors to ramp up to 2,000. Right? Let's see what happens. Nothing happens. Did I actually connect them? Ha! I didn't connect them. Guys, I'm so embarrassed right now. Oh, no, it's still your fault. All right, so we've connected them. Now let's see what happens. All right, look at that. Yay, it's actually... Now, there's a problem here. Watch this. See our front wheels wobbling? Somebody nod, say yes. Yeah. All right. So our front wheels are wobbling. The problem is the dynamics and the steering are trying to engage at the same time, and the dynamics doesn't have a frame to go off of before that in order to figure out like the alignment of the wheels. So thanks to my sort of friend, Thanasis or Noseman, we sat through a 3-hour Skype session trying to figure this out. And all that needs to happen is we need to tell the rotation H values not to output before frame 5. So we're going to I'm going to run through this pretty quick because I got about 5 minutes. This time node here, we're going to switch this to frames. We're going to delete this port, optimize, and we want to say, so we're going to put in a condition node, logic. I'm sorry, we're going to do a compare node first. And what we want to do is we want to feed our frame number into the input of the compare, and we want to say if it is not greater, if the value coming in is not greater than 5, don't let anything pass through. And the way we keep things from passing through is we use a condition node. This is going to control a switch. It's going to say flip the switch after frame 5 and go to input 2. And if it's not flipped, then stay on input 1. One of those inputs is going to be 0 because it's going to be a 0 steering angle for straight. So we're going to feed this into the switch, and we're going to feed our rotation H into this input. So this is saying if time is greater than frame 5, then switch to this input and output that value. If time is less than frame 5, then output input 1, which is 0 degrees rotation, right? So let's just try that out and see if it works. All right. Right, no more wobbly tires. Steering doesn't change until frame 5. And you can see this is following this sphere on out. And you can loosen up the friction on the back wheels and have it do a power slide and do cool stuff and all that stuff. And when it comes close to it again, it comes to a stop on its own. Now, this is not limited to a sphere on a spline. You can have it follow anything, another car, whatever you want. You just need to put the follow target into the pointer. So let's just take that spline off. And let's just have fun. Let's just play. Hit play, grab the sphere, and just drag it around. Oh, God, I need to turn the body cam off. Here we go. So there's one more thing we need to do, and that's it. You can see those wheels are turning ridiculous all the way around, freaking it out. Simple to fix on our pointer. We just need to put a protection tag, and we want to limit the heading rotation to negative 45 degrees and 45 degrees, saying you cannot turn past this and you cannot turn past this. You may not pass. And let's grab this again, run it, and now it doesn't turn past 45. And now you can do cool little power slides with it and get fully dynamic. It's pretty cool, right? Thank you. Game of Thrones. Thank you, Maxon. Thank you, everybody, for having me here. It's awesome to be able to give back to the C4D community because I've taken so much knowledge from you guys already. If you have questions, I'll be in the back, and you can find me on Fivetengiant.com. I actually had to buy 510giant.com because somebody typed that in, so you can type that in too. And thank you, everybody.